For this part of our test review, we're going to look at exponential growth and decay. So we want to state whether each of the following is an example of growth or decay. So in this first graph, we can tell that from left to right, it is going down. So we would say that that is decay. And again, you read a graph left to right when we're looking for this. In the next example, it's rising from left to right. So we would say that this graph represents a growth equation. And in the third graph, the same thing. It's rising from left to right, so that would be growth. And in the fourth graph, it is falling from left to right, so that would be decay. In the equations underneath there, we look at the base b, and then we also pay attention to the exponent in case it is a negative x right there. So 0.99 is less than 1, so that would be decay. Here we have 4 as our base, but we have a negative 2 as our exponent. So it'd be like 4 that gets moved to the denominator, which would be a 4 squared. So 4 to the negative 2 power gets rewritten as 1 over 4 squared, and then it would be less than 1, so this would be decay. So even though it starts out as a 4, it turns out to be a decay function. And then in the next example, we have 1 over pi. Notice we're only looking at the base b because it's written in the form we've talked about in class, where we do have an a out front, but what determines growth or decay is the b value. So that b is 1 over pi, which is 1 over 3.14 approximately, which is definitely less than 1, so that would just be decay again. And then in the last example, we have 0.853, so that would also be decay because it's just less than 1.